The pump is running. It has been running since the summer of 1938, when the world was occupied with other concerns, and a London County Council engineer signed off on 2 horizontal pressure filtration vessels, each 8 feet in diameter and 28.5 feet long, installed beneath a single-story brick building on Hampstead Heath. That building is still there. The pump house, Grade 2, listed and architecturally unremarkable from the outside, sits at the east end of Parliament Hill Fields, Lido. Inside, showed the infrastructure that Herbert Morrison's 1937 ambition to make London a city of Lidos brought into being continues to do precisely what it was specified to do. Water enters, water moves, water is cleaned. The permuted Venturi-controlled proportioning apparatus, a name that sounds like something a Victorian engineer invented on a dare, measures coagulating chemicals in grains per hour and delivers them in exact proportion to the water flow. It has been doing this for 88 years. The pool itself is 61 meters by 27. Its depth runs from 2.5 feet to 9.5. It holds 650,000 gallons of water. The filtration system processes 1.6 million gallons every time. In 1937, the London County Council leader Herbert Morrison announced his intention to make London a city of Lidos. This was not a vague aspiration. It was a procurement brief. The engineers in the LCC Parks Department, Harold Rowbotham and T.L. Smithson, were given an envelope of £34,000, which was the most expensive allocation of the 13 Lido projects completed between the wars. They were not told to build something cheap. They were told to build something that worked. The brief demanded a filtration system capable of cycling the entire pool volume in 5 hours. At 650,000 gallons, that required a sustained throughput of 130,000 gallons per hour. The solution was 2 horizontal pressure filters, each 8 feet in diameter, 28 feet 6 inches long, with a combined filtration area of 236 square feet, operating at a filtration speed of 275 gallons per square foot per hour. The arithmetic was precise. The engineering was done once, and done correctly. Yet the water was to be treated before filtration by a permuted Venturi-controlled proportioning apparatus, a system that dosed sulfate of alumina and soda in proportion to flow rate, measured in thousands of grains per hour, displayed on a control panel described in the original 1938 trade press as of neat and attractive design. They were not wrong about the design. They were also not wrong about the engineering. Bronze impeller pumps were not the cheapest option available in 1938. Cast iron pressure filter housings were not the lightest. Neither decision was made carelessly. Bronze resists chlorine. Cast iron, properly maintained and properly coated, resists corrosion across timescales that make procurement accountants uncomfortable. The choice of these materials was not romantic. It was arithmetical. A pump that lasts 80 years costs less per decade than a pump replaced every 15. The mathematics of this are not complicated. What is remarkable is how rarely they have been applied since. The 2 pressure vessels delivered from G, Walker and Slater's contractors and installed in the East Filtration Building were designed to be opened. Access flanges were specified, not bolted closed against future inspection, but bolted in a pattern that any competent engineer with a standard set of British Standard Whitworth tools could reverse. The internal filtration media could be removed, inspected, replaced. The shell would remain. The shell did remain. Bronze impellers, rotating components that drive water through the system, were specified for their corrosion resistance in chlorinated environments and for their capacity to be rebalanced and reseated without replacement of the casing. The casing was cast iron. The casing was the asset. The impeller was the service item. This distinction between the structure that endures and the component that wears was the foundational engineering decision at Parliament Hill Fields in 1938. It is also the distinction that modern pool equipment design has almost entirely abandoned. A contemporary residential pool pump is designed as a sealed unit. The impeller, the housing, and the motor are combined into a single assembly. When it fails, the assembly is replaced. When the assembly is replaced, the manufacturer is paid again. In 1938, this was called a design error. The pump house at Parliament Hill Fields is not large. It is, by the standards of industrial buildings, modest. What it is not is accidental. The ceiling height was specified to allow a block and tackle to be rigged over the filter vessels without the need for external lifting equipment. The access corridor between the two filter housings was set at a width that two engineers working together could occupy without difficulty. The pipework was routed above head height on the south wall, visible, labelled, accessible from a standard workshop stepladder. The isolation valves were placed at arm's reach. None of this happened by chance. It was designed by people who understood that maintenance is not an emergency. It is a scheduled event. A building that treats scheduled events as emergencies has been designed incorrectly. The original 1938 issue of Baths and Bath Engineering described the control panel as bearing reagent flow indicators mounted on a control panel of neat and attractive design. What the trade press did not remark upon, because in 1938 it was too obvious to require comment, was that every instrument on that panel was at eye level, every valve at hand height, and every indicator scale readable without the aid of a torch. The pump house was an argument made in brickwork and pipework. Yet the argument was, whoever maintains this in 50 years should be able to do so without difficulty. They were right. As it turned out, they should have said 100. 275 gallons per square foot per hour. That is not a number arrived at by approximation. The 1938 engineers knew that too slow a filtration rate would allow biological growth within the filter bed. Too fast, and the coagulated particles, the sulfate of alumina and soda, had already done their work, binding suspended matter into heavier flock, would break through the filter medium and return to the pool. 275 was the rate at which the filter could reliably remove particles without breakthrough, so that the flow volumes required to turn over a pool of 650,000 gallons in the specified 5 hours. Combined filtration area, 236 square feet. Required throughput for a 5-hour cycle, 130,000 gallons per hour. Divide throughput by area, 275 gallons per square foot per hour. The arithmetic is exact. The fact that it appears in a 1938 trade publication without commentary suggests that it was considered routine. The fact that the system was sized correctly and has continued to operate within those parameters across 8 decades suggests that routine engineering, done carefully, has a longer service life than innovative engineering done in a hurry. The cascade aerator at the west end of the pool, the ornamental wedding cake feature that visitors have photographed for 88 years, was not decorative in origin. Water emerging from the pressure filters had been chemically processed and mechanically filtered. It required reoxygenation before return to the pool, and the cascade achieved this by exposing the water surface to air across multiple tiers. The engineers called it a cascade aerator. The public called it a fountain. Both were correct, and neither description required the other. Let us be precise about what the 2004 refurbishment changed, and what it did not. The stainless steel pool lining was new. The original blue glazed brickwork, supplied in 1937 by the Lilleshall Company of Priors Lee Hall near Shifnal, had done its job. It was not failing. It was, however, leaking at the grouted joints in a manner consistent with 67 years of thermal cycling and bather loading. The stainless steel lining, 2 millimeters thick and dimpled, addressed the leakage. The Lilleshall brickwork remains beneath it. The filtration system was improved. The word used by the operating authority is improved. This is accurate. The 1938 pressure vessels were supplemented with upgraded dosing and flow monitoring equipment. The pump housings, the cast iron casings that have stood at the east end of the building since 1938, were not removed. They were assessed. They were found serviceable. Bearings were renewed. Seals were replaced. The pump housings remained. The permuted proportioning apparatus had been updated in stages over the preceding decades. As the precision of chemical dosing technology improved, the principle, Venturi-controlled, flow-proportional chemical addition, remained intact. The control panel was replaced with instruments readable to finer tolerances. The cascade aerator was restored, not replaced, restored. The clock on the poolside wall, a feature noted in early photographs of the Lido, was also restored. It had stopped. It was repaired. It continues to tell the correct time. And the original engineers would have considered this entirely unremarkable. In 1986, Parliament Hill Lido recorded 12,700 users for the season. In 1987, 19,000. These numbers were improvements. They were not reassurance. The Greater London Council, in the years before its abolition by the Local Government Act of 1985, had debated closing the Lido. A roof cover and site redesign had been proposed. The plans included a wave machine, an artificial island, a wall of vegetation in the pool. None of these proposals were engineering solutions. They were attempts to make a perfectly functional piece of infrastructure appear to require the kind of capital investment that would justify keeping it open. The wave machine was not specified because the pool needed a wave machine. It was specified because the pool needed a budget allocation, and the budget allocation needed a justification, and a justification required the appearance of improvement. The GLC was abolished in 1986. The Lido passed to the London Residuary Body. In 1989, along with Hampstead Heath itself, it was transferred to the Corporation of the City of London. The Corporation of the City of London did not install a wave machine. In 1999, Parliament Hill Field's Lido was Grade 2 listed, recognised as the finest surviving example of an urban Lido constructed between the wars. This listing did not happen because the building was attractive. It happened because the building was still working. The wave machine proposal was not revisited. It is not recorded whether the pump expressed an opinion. The Corporation of the City of London has managed Hampstead Heath and its facilities since 1989. The Lido, as a Grade 2 listed operational site, requires maintenance staff who understand not only the current equipment, but the reasons the current equipment is arranged as it is. This knowledge is not in the instruction manuals. The instruction manuals, to the extent that they exist in updated form, describe what the equipment does and how to operate it. They do not describe why the isolation valve on the north inlet is the first to be closed during a filter backwash, or why the specific sequence of the dosing system requires the soda addition to precede the sulfate of alumina by a measured interval. These things are known by the people who operate the plant, and they are known because someone who was there before them took the time to explain it. This is the engineering knowledge that built systems like Parliament Hill Fields, the knowledge that the impeller housing must be inspected from a specific angle to see the wear pattern correctly, the knowledge of which thread lubricant is correct for the inspection port fasteners, not the modern substitute, but the one that works with the original thread form and the original material. The City of London Corporation's maintenance culture at Hampstead Heath is not incidental to the Lido's survival. It is causal. The pump has not been running for 88 years because the original engineers were extraordinary. It has been running for 88 years because every engineer since has treated the machine as something worth understanding. Parliament Hill Field's Lido is not famous for its engineering. It is famous for being cold, for being beautiful in a way that only unheated outdoor pools in British climates can be, and for the quality of light on the water early in the morning when the heath is quiet and the filtration system has done its overnight work without complaint. The engineering is why those things continue to be possible. The original 1938 design philosophy, specify for service life, not procurement cost, design access for the maintainer, not the manufacturer. I choose materials for the century, not the decade, has produced 88 years of uninterrupted municipal swimming on Hampstead Heath. The counter-proposal was a wave machine, 13,000 users a season, and a decommissioning review. The choice between these outcomes was made in 1937 by two Parks Department architects and the engineers who specified the filter vessels, the impeller housings, the permuted dosing apparatus, and the cascade aerator. They did not design for obsolescence. They did not specify a service life of 20 years and move on. But they built a machine that could be maintained by the next engineer with tools the next engineer would already own, and they housed it in a building that assumed the next engineer would arrive. The next engineer has been arriving every maintenance cycle for 88 years. 13 Lidos were built by the London County Council between 1909 and 1939. Parliament Hill Fields is one of 4 still in operation. The other 9 were not maintained into obsolescence. They were maintained into closure, and then they were closed because maintaining them had stopped. The distinction matters. The pump is still running. It will be running tomorrow. It will require maintenance on its regular schedule. The filter backwash, the chemical dosing check, the bearing inspection interval that the maintenance record shows has been followed consistently since a time when the man who set it could have spoken to the engineers who specified it. The parts are obtainable. The knowledge exists. Yet the institutional will to continue is present in the form of a Grade 2 listed operational site managed by an organization that has existed in various forms since 1067. The City of London Corporation has been maintaining things longer than most engineering companies have been designing them. None of this is extraordinary. It is simply what happens when a piece of public infrastructure is built correctly, maintained continuously, and never subjected to the assumption that replacement is preferable to repair. The GLC wanted a wave machine. Parliament Hill Fields got 88 years of clean water delivered at 275 gallons per square foot per hour because 2 engineers in 1937 read the brief correctly and specified accordingly. The brief said, "Build something that works." They did.